Good evening, everyone.
Good evening, sir.
Good evening, sir.
So actually today what we are discussing is not part of the syllabus. Yes, we will discuss 2-3 numericals. It's actually very simple. Uguay graph. Less than Uguay, more than Uguay, which is not in the syllabus for this year. It's very simple. Just if you know how to calculate the cumulative frequency, then you can able to do graphical method of finding the mean. I will start with a question. We are having the different method and we know how to do the cumulative frequencies. It's a simple. I will give a data. Just we'll see. I'm having a frequency distribution like this.
Sir, are you sharing the screen, sir?
Minute. Yes, sharing. Yeah. This is a class group 5 to 10, 10 to 15, 15 to 20, 20 to 25, 25 to 30, 30 to 35, 35 to 40. Number of shops, frequency of that particular gas. 2, 12, 2, 4, 3, 4, 3. So how to do with the graphical method? So upper limit means less than OB graph. So I'm taking upper limit. Upper limit means what kind of cumulative frequency will get? Less than cumulative frequency, less than, correct?
Yes, sir.
Less than, sir.
Upper limit gives what is the upper limit will gives? Less than type. So if I'm writing less than type cumulative frequency, what I will get? Less than type cumulative frequency. Less than 10. How much? Less than 10, how many?
2.
Less than 10, correct? 2. Less than 15? This is less than 10.
14.
Less than 10. Less than 15? 14.
14.
Less than 20? 16.
16.
Less than 25? 20.
20.
20,
23.
23.
5.
27.
27,
30.
30.
Now using this this is called upper limits. I'm taking upper limits as the x coordinate, x-axis, and frequency, cumulative frequency as the y-axis. If I'm drawing a graph, it will give a graph. So first coordinate is how much? 10, 2. Suppose if I'm taking 1, 10, each centimeter I'm taking 20, 30, 40, 50, 60, 70, 80, 90, 100. Here I'm taking the scale, the maximum number is 30. So I'm taking 3, 6, 9, and 11, 12, 15, 18, 21. Whatever the graph you want, you can take. Multiples of 2 also is okay. Multiples of 5 is also fine. 24 and 27 and 30. So what is the x coordinate? 10, 10, 2. So 2 is somewhere here. Next one is 15 comma 14. 15 is, where is the 15? Between 20 and 50. So 10 to 15, 30 to 40. So 15 is somewhere here. 15 comma 14. So 12 somewhere here. This is. Next one is 20 comma 16. Next one is 25 comma 20. 25. Sorry guys, some mistake. Scale mistake I done. Instead of taking 10 to 100, what scale is better? I can take 10, 15, 20, 25. Each one is 5, 10, 15, 20, 25, 30, 35, 40. Now you will get a clear scale. 10, if I am taking this is 2, 4, 6, 8, 10, this is 12, 14, 16, 17, 18, 20, 22, but the graph is coming differently. 22, 24, 26, 28 and 30. 28, 30. 5, the first coordinate is how much? 10 to 15, 14. 10 to 15 and 14. This is the second graph. And 20 and 16. 25 and 20. 25, this is a 25 line, this is 20. 30, 23. This is 30 line. 23 is in between 22 and 24. This is 30th line. And when it comes to 35, it's 27. 27 is here. And this is the last one. So if I'm joining the graph like this graph is called, you are taking the upper limits. You are taking you should not cross this box. This, because 10 to 15, it should lies between only 2 to 14 only. So this is called less than ogive or ogive graph. Suppose if I am taking more than, that is lower limits, I will get more than ogive graph. More than ogive graph is a decreasing graph. Less than ogive graph is a increasing graph. To calculate the mean, there are different methods. You can find out only using less than ogive. You can find out only using greater than, more than ogive, or combination of both. So the accurate method is combination of both. If I'm taking the same cumulative frequency with more than type, if I'm taking more than type, what I will get? What are the coordinates I will get if I'm taking more than type? If I'm taking more than type, what are the frequencies I will get here? If I'm taking more than or equal to something, more than or equal to, lower limits I have to take. More than 5, more than 10, more than 15, more than 20, more than 25, more than 30, more than 35, and more than 40, it will become 0. More than 40 will become 0. If I'm taking more than 5, it will be 30. Everything. 30 minus 2, more than 10 will be equal to 28. More than 15 will be equal to how much? More than 15 is how much? 28 minus 14. 14. More than 20 will be equal to 14 minus 2. 12. 12 minus 4. 8. 8 minus 3. 5. 5 minus 4. 1 is coming. How it is possible? It should end with 35 to 40. More than 35, it should be 3 now. Where we are doing mistakes. Guys, more than graph, more than cumulative frequency, how much we are getting? Let me know. More than 5 is 2, and more than 10 is, sorry, more than 5 is everything. So that is 30. More than 10 is 30 minus 2, 28. And more than 15 is how much? 28 minus 14. So 14. And more than 20 is how much? More than 20 is how much? Thirty, 16. More than 20. 4 plus 3 plus 4 plus 3. So 14. Huh? Guys, Niranjan, more than graph. Cumulative frequency or more than graph. You with the same data. This is 30. From here, 30. From here, 28. From here, 2 plus 4, 6, 9. 9 plus 4. 9 plus 4, 13, 13 plus 3. This is 16. Sorry, guys. This is 16. And this is 14. And this is 10. And this is 7. And this is 3. If I am taking, these are the coordinates. If I am taking the graph, so 5 comma 30, I will get another graph. If you draw in the same graph, 5 comma 30. So 5 is here, 30 is in the topmost. And 10 comma 28. 15 comma 16. 16 is here. 20 comma 14. 25 comma 10. So the graph will come like this. So the meeting point, this is the mean where both the graphs will meet. This is called more than value. The mean is coming in between. What are the point? Intersection point. It's coming exactly around 15 is the mean. Around 15 or 16 something. 15 or 17.5. Exactly. If I am drawing a graph paper, you will get accurate value. It is coming in and around 15. It is coming in and around 15. This is how you can calculate the mean using the both the graphs. Suppose if I want to find out only with the one graph, what value I have to consider? What value I have to consider? Which value will make just take the average of frequency, so 15, and draw the intersection point 15 where it is intersecting the graph. There you will get the median class. Median or mean. Sorry, it's a median. So for this year, they actually omitted from the syllabus. So any doubts? Anyway, this I am not going to assess for your examination, and it is not going to continue. Who are willing to take statistics in our future, like MS, BSc statistics, or going for some business kind of thing, it will be useful for you. So shall I wind up this topic? Will you complete first 3 exercises? When you ready bounds, I will explain you separately this one. Guys?
Yes, sir.
Yes, sir.
Okay, sir.
Anyone wants, I will explain you. We'll make a session and I will explain you deeply, because the textbook is just given the briefing of the topic. We can learn a little bit more related to graphs, how to find out the mean, median, and mode using the UV graphs, but we are having only median from the graph. Just you have to find out the lower limits and draw the graph, upper limits and draw the graph. Both the intersection points will give the median class. So this is how we can able to calculate the median or mean from the Wigway graphs. So this is a graphical method, I think, which is completely eliminated from the syllabus. Just let me check. So statistics, step deviation method is also not there. Step deviation method for finding the mean is not there. Cumulative frequency graphs also not there. So keep it in mind when you are practicing the things. For knowledge purpose, if you want, I will help you. Is it clear? Shall I move to the next topic? Probability, one of the easiest topic, where it will be useful in your +2 and +1 a lot. Minimum 10 marks, 8 to 10 marks, you can expect board marks in +2. Shall I wind up the statistics? Any doubts in the statistics or anything need to be discussed in the statistics? Shall I move to the next one?
Yes, sir.
Guys,
Yes, sir.
Yes, sir.
I am taking the probability concepts. Anyone having any idea what is the meaning of probability? What we done in 9th standard?
The probability means guessing something which will happen or which will not happen.
Only guessing. Even the guessing also, how much you can able to achieve, how much you can able to success. That is also important now. Not
Yes,
only
sir.
guessing, your guess should be surely how much it can success. Percentage of success, calculating the percentage of your guessing will be true. That's the generally is called a probability. Probability means estimating where, based on the previous events, based on the some data, how we can expect what can be happen, how it will be happen in real time scenarios, based on the 100 years the rain data they will take and they will observe, based on climatic conditions and based on the winds flowing around the globe, how upcoming 25 years it will affect, it will affect the things, uh, or if they are taking any consumers in past 10 years, how the sales was gone, on what basis the sales are gone up and down, what factors affecting the sales. Based on this, they can predict the sales of coming year, and so much of thing they can do. For that, probability is like an ocean. It's like only the basics. Only we are learning the ABCs of the probability till +1. +2 only, at least we will do something related to practical. Something related to practically we will do probability, but till +1, we will do general basics of the probability. Just so anyone can introduce what we done in 9th standard in probability. The continuation of that only here. Anyone? Guys, Sandhya or
We found
Niranjan?
the chance of the percentage of the outcome.
Percentage of the outcome. Next.
The experiential outcome.
You're doing any experiments? How far? How much percentage of success?
Yes, sir. Like tossing the coin.
Yes. Any others? Any other? What kind of questions you solved in the 9th standard?
Sir, dice related and
Dice
card.
related. Yeah. See, what is the meaning of I'm tossing a coin? You are expecting. What is the meaning? Can you say anything? You are doing something. That means you are doing some experiment. It's an experiment. You can do so many experiments, but each experiment you can predict what kind of result comes, but there are some experiments you can't predict what kind of results will come. So suppose if I'm tossing a coin is an experiment. but you know all the results outcomes. What are the results outcomes for a tossing a coin?
Heads and tails.
Heads and
So
tails.
heads or tails.
Heads or tails. So that you know, in this experiment, you know all the events. All the events means getting the head is called one event. Getting the tail is called one event. Other than that, you don't know. It is no events will occur, correct? Other than that, there is no event will occur in this experiment, correct? So, in this experiment, you can predict what kind of outcomes can come. But in future, we will deal the things which is like many. Suppose, best example, I'm having a playing cards. I'm having playing cards, a set of playing cards. Suppose if I'm taking a card randomly, playing cards is having 52 cards. 52 cards. 52 cards. And each card is like numbered with A, 2, 3, 4, 10, Jack, Queen, and King. And two sets are black, two sets are red, and four symbols. There are so many combinations here. Heart symbol, spade symbol, clover symbol, and diamond. Generally, heart and spade are black. Spade and clover are black. These two things are red. If anybody knows the cards concept, I think everybody knows cards, playing cards. So
Yes.
there are four
Yes,
sets, two colors, four symbols, total 52 cards. If I am drawing randomly, how many events can occur? Anyone can guess how many events can occur? There are n number of questions you can frame from this experiment. See, if I'm tossing a coin, I can frame hardly 1, 2, or 3 questions. Tossing a coin, I can give only maximum 2, either tail or either head. But if I'm tossing 2 times, if I'm tossing 3 times, if I'm tossing 4 times, then the combinations will be different. You can ask so many outcomes. You can ask so many outcomes means what is the chances of getting continuous 2 heads? What is the chances of getting head tail? What is the chances of getting all our heads? What is the chance of getting all our tails? So these are the called particular events in that experiments. Like this, if I am taking one card from the set, what is the probability of getting number 4? What is the probability of getting number 5? What is the probability of getting number 10? Like this, you can ask n number of questions. That is, there are so many possibilities here. So many events can occur, correct?
Yes,
Now
sir.
understand what is the meaning of an event. Event is an outcome of an experiment. If you are tossing a coin is an experiment, getting the head or tail is a 2 events. Getting the head is one event, getting the tail is another event. Like that, each and every experiment have so many events, but we are learning only the 2 scenarios. One is tossing a coin. For our 10th standard level, we are going with only 2 scenarios, and 11th and 12th we will go with the cards also. Yes, we are going to learn here tossing a coin or tossing 2 coins, hardly maximum 3 coins. Tossing 2 dice maximum. Tossing 2 dice. Now we'll see. So these are the 2 experiments, either with coin or dice only we are going to discuss here. Just before going to this, what we discussed in 9th standard, again I'm going to discuss a probability of theoretical approach, which I already told you. Anyone can tell what is the meaning of probability? Before getting the result, predicting the result is called probability, based on the uh, past experiences in the data. Using the data what we have, we can predict. So if I'm tossing a coin, based on my previous experience, I can find out it may be tail or it may be head. So before getting the result, both is having same percentage of chances to get the thing. So how many possible outcomes? How many possible outcomes? That is called number of trials. And different books it is having different names. Are sample space. Sample space. But here we are going to discuss as number of trials. Out of number of trials, only few things will occur after completion of the trial. Few things will occur. Any one thing only will occur in case of a coin. So from here, we can say, if I'm expecting one event, in an experiment, that means I'm performing an experiment. Listen, guys, clearly. It's interesting if you keep it in mind. And I know what are the possible events. What are the possible events? That means I am tossing a coin. I am tossing a coin. So the tossing a coin is my experiment. And what are the possible events? The result may be head, the result may be time. But my question, my requirement is, what is the probability of getting head? For example, that means out of all the events, how many events are favorable to your requirement? This is called your favorable number of favorable events. Whatever the thing the question is asking, that event is called favorable event. Favorable event. That requirement is called favorable event. This kind of approach is called theoretical approach or classical approach. We are having only classical approach. Mathematical related, using permutations and combinations, using the statistics, we can able to calculate the probability. That is a different thing that we will start in +2. So now probability of getting head. So from here I can explain the probability of getting an event. In this case, my event is getting a head will be equal to number of outcomes or number of trials which is favorable to the event. Number of outcomes favorable to the event. Whatever the event the question is asking, divided by number of all possible outcomes. So for coin and dice and all, it is countable, but there are the situations which is not countable. For example, if I'm having 52 cards, what is the probability of getting the number is 2? There are 52 ways to draw the card. So 52 events can occur here. But out of 52 events, 4 only favorable to you, because you may have 2 with 4 symbols. So you are having 52 all possible events, but in that 4 is only favorable to your requirement. So that is the meaning of outcomes favorable to the event. That is purely depends upon the question, which question are asking. And number of possible outcomes, this is completely depends upon what experiment you are performing. So in 10th standard maximum, we are having 1 coin or 2 coin or 3 coin or 1 die, 2 dice. So only 5, maximum 5 only we are having. 5 experiments only. Based on this only, all kind of questions they may ask here. Based on this only, all kind of questions they may ask here. So that's the reason at the end of the topic, what we will do is we will write the sample space for all the 5 experiments. If you know the sample space, any kind of questions, even 100 questions, 200 questions, also asking out of this experiment, you can able to answer very easily. No, only one thing we are going to remembering is probability of an event is equal to number of possible outcomes divided by total number of outcomes. So the question was, if I'm tossing a head, if I'm tossing a coin, what is the probability of getting head, guys? Probability of getting head. This
1
symbol
by
represents. So if I'm tossing, it may be head or it may be tail. So my total number of outcomes is head or tail. But out of I want only head. So one event favorable divided by total number of events is 2. The meaning of this is the probability of not getting head. That means other than head, anything. In this case, what is the meaning? Probability of getting tail. So that is 1 by 2. So for this, I can write as probability 1 minus probability of getting head, because the total probability is always 1. Anybody can explain why the total probability is only 1? See, probability explains the percentage of winning scenario. Whenever I'm talking about the percentage, means it is restricted to 100. You are calculating the fractional chance of getting your requirement. Fractional is always calculated for 1. So it is never greater than 1. Never greater than 1 means if I'm taking it is equal to 1 or greater than 1, what will happen? Each and every time your requirement is coming. That means if I'm taking probability of getting hit is 1. That means each and every time you will get hit only. Each and every time you will get a hit only. So that is not possible in real scenarios. Now, one question I'm going to give it to you. A bag contains a red ball, a blue ball, and a yellow ball. A bag. There is a bag. It contains a red ball, a yellow ball, and a blue ball. All the balls are being same size. So it's identical. By seeing only, you can able to identify what is the color of the ball. Suppose a student wants to take one ball from it. A student will get only one chance to get the ball. So what is the probability of getting yellow ball? What is the probability of getting red ball? What is the probability of getting blue ball? How you can explain this question, Sandhya? This symbol is probability of getting yellow. The symbol is probability of getting red. This is the probability of getting blue. So what is the total possible? There are 3 possible events can occur, correct?
Yes, sir.
Total possible events are what are the total possible events? If I'm taking one ball, I may get red, I may get yellow, I may get blue. But I'm having only one chance. I'm having only one chance to pick the ball. So probability of getting yellow means there are only 3 balls. Out of 3, there is only one yellow ball, correct? So 1 by 3. Here also 1 by 3. Here also 1 by 3. Suppose if I'm not asking what is the probability of getting not a yellow ball. What is the meaning of not a yellow ball? Other than yellow, everything, correct? Correct or not?
Yes.
So 1 by 3 plus 1 by 3. Why 1 by 3 plus 1 by 3? Why 1 by 3 plus 1 by 3? That means I don't want yellow. So your chances is more or less here. So that means indirectly what he is asking, not a yellow ball means probability of getting either red or black. Sorry, blue. It may be anything. That's the reason there are two possibilities out of three. So even like this also I can able to calculate. It may be probability of getting either red or blue. So there are two favorable outcomes out of three. So your probability is 2 by 3. So percentage of getting that is 2 by 3. 2 by 3 means you will get around 66.6%. Is it clear, guys? What is the exact meaning of probability? So we are restricted for only simple experiments, but when it comes to little higher studies, it may be uncountable experiments also we will do. There are certain things which is not so easy to count. Those kind of experiments also will calculate the probabilities. Is it clear? Guys, is it clear?
Yes.
Shall I move to the one more
Yes,
question?
sir. Yes,
Yes,
sir.
sir.
What is the sample space of a die? If I throw one die, if I throw a die, what is the total possible outcomes? How many? The result may be 1, maybe 2, maybe 3, maybe 4, maybe 5, maybe 6. Am I right? Is it right, guys?
Yes, sir.
There are 6 results can occur. Is there any possibility other than this? No. Correct?
Yes, sir.
Yeah. But based on this, I can ask n number of questions. What is the probability of getting? You have to solve this question, guys. Everyone, probability of getting even number, probability of getting even prime, probability of getting odd prime, sorry, odd number, not odd prime, sorry, and probability of getting prime number, and probability of getting composite number. Can you able to do all 4 questions?
So probability of even number will be 1 by 3.
Probability of 1 by 3. Is it right?
Yes, sir, because there are
What is the
3
probability
even
of
numbers
getting
and 3 even numbers and total 6. So 3 and 6 will get cancelled as 1 by 3.
by 2?
Even prime is 1 by 3, sir.
So
Even
1 by
prime.
6. 1 by 6, sir. Only 2 is an even prime.
Even prime is, there is only 1. 1 by 6. Odd number is 3 by 6.
Again 1 by 2.
Prime number is prime number. Probability of prime.
So 1 by 2, sir.
1 by 2. 1 by 2.
3 by 6. By 2. Because the prime numbers are 2, 3, 5. Odd numbers are 1, 3, sorry, 5.
1, 3, 5.
Even numbers are 2, 4, 6. Even, sorry, 2, 4, 6. Even prime is only 2. Now, what is the probability of getting a number greater than 4? Probability
3,
of
sir.
1 by 3, sir.
getting greater than 4. So only 5 comma 6 out of all. So 2 by 6. So 1 by 3. If I am saying greater than or equal to 4, probability of
1
getting
by
a
1 by
number
2.
1 by 2. So 3 by 6. So observe or understand the question exactly what they are asking. Probability of getting greater than 6.
0 by 6.
0. Probability of getting greater than or equal to 6.
1 by 6.
1 by 6.
probability of getting a perfect square?
One by three, sir.
Why?
Sir, 1 square is 1, 2 square is equal to 4. So 2 numbers is 1 by 3.
Super. A requirement is 1 comma 4. There are 6 possible outcomes, but I want only these 2 favorable for me. So 2 by 6, that is 1 by 3. This is how you can calculate any kind of questions related. They may ask anything. It's not restricted. These are some sample questions, which is now. The question is, what is the probability of getting a number less than or equal to 4? Probability of getting a
2 by
number probability of getting a number less than or equal to 4. So how many numbers are less than or equal to 4? 4 by 6, that is 2 by 3. Yeah. Next, probability of getting multiples of 2.
1 by 2.
What are the multiples of 2, Sandhya? 2, 4, 6. So total 3. So 1 by 2. Multiples of 3. Probability of getting multiples of 3. 1 by 3, yeah?
Yes, sir.
Yes, sir.
Probability of getting multiples of 6.
1 by 6.
By
1 by
6. So like this, they may ask n questions, n number of questions, but all the questions is within our sample space only. They won't go beyond the sample space. Now, what is the meaning of complementary? Complementary. Mathematically, I will tell you, then we can get one idea what is the meaning of complementary. Suppose if I am asking, I throwed you a die. And I am asking, what is the probability of getting a number 4? Suppose this is getting a number 4. It is one event. The complementary of this event is nothing but complement of this event is nothing but, which is not true. Whatever statement you are getting, opposite to that, it's not true. The true statement is getting a number 4. The complement is probability of not getting number 4. This is called probability of 4. The bar symbol will explain complementary of that particular event. Suppose P of E an event, P of E bar is the complementary of that. The relation between complementary and its event, probability of an event and its complementary is the sum of an event, its complementary event is always 1. For example, if I am saying the probability of getting number 4 is 1 by 6, then what is the probability of not getting 4? That means 1, 2, 3, 5, 6. It's a 5 by 6. So what is the addition of both the probabilities? This is probability of getting 4 and this is probability of not getting 4. If I'm adding both the probabilities, I will get 1 only. So the relation between a probability of an event, its complement will be equal to sum of both the probabilities is equal to 1, or probability of an event will be equal to 1 minus probability of its complement, or probability of a complement of an event will be equal to 1 minus probability of that event. So any relation you can able to keep it in mind. This is the relation between a probability of an event and its complement. Complement is nothing but which is not true. Which is not true of the given event. which is not true of the given entity, which is happening if you are asking, how much chances are there for not happening. That is only the complementary. Guys, anyone is clear with the complementary? Not clear, please let me know, guys. I will move to some questions. Complementary concept will be useful in some cases where your possible event is very huge, it is not so easy to calculate. We'll go with some examples. If you're clear with the complementary, I will go for some numericals. If you're clear, I will go. Response from you people, guys?
Clear, sir.
Clear, sir.
Yeah. Now, with respect to just make a note of a question. Meanwhile, I will update the attendance. Now, one card is drawn from a well shuffled deck of 52 cards. One card is drawn from a well shuffled deck of or pack of 52 cards. Calculate the probability of that will give, or the probability that will give. The first one is be an ace. The second one is not be an ace. For that, you have to know how many ace cards will be there, how many colors will be there. Everything you have to know. Anyone can explain the structure of the deck? How the 50 cards will be distributed? How? Sandhya, any idea? First, we will see how many cards, how the cards will be distributed. After that, only we can go. There are many ways you can explain. See, make a note if you want. 52 cards. It's simple. So, 3 categories: color, symbol, and numbers. Suppose if I'm taking colors, there are 2 colors in this. What are the 2 colors, guys? Black and red. Again, black is divided into 2 symbols. You will get a black club. This is called club, and black spade. This is called spade. And when it comes to red color, we are having again 2 symbols in the red color: diamonds and hearts. And each sector, this is called set 1, set 2, set 3, set 4. The numbering will be common. Each club of black color from ace, 2, 3, 4, 5, 6, 7, 8, 9, 10, jockey, queen, and king. So if you look into this, total 13 cards. With the same kind of numbers, 13 more cards. Same kind of 13 more cards. The same kind, 13 more cards. So now 4 into 13 is total 52 cards. This is the structure of the total set of a pack, like cards, playing cards. Is it clear, guys? With this, we will get n number of, see, using 6 outcomes only, we are having n number of questions. So with these combinations, you may get infinity questions also. So there is n number of events might be asked. Is it clear how the cards, how many cards can be possible? Guys, is it clear?
Yes, sir.
So shall I go for the questions related to this?
Yes, sir.
Yes, sir.
Yeah. So what is the questions? Getting one card and that card must be an ace. So total how many are there? Total how many are there? Total 52. There are 52 cards. And I want to draw one card. And that card must be ace card. So how many aces are available in 52 cards? How many aces are available in 52 cards?
4.
To answering the questions, the number of outcomes favorable to E. What is your E here? Getting an ace out of a well shuffled pack. So the number of outcomes favorable to E, 4. So number of possible outcomes, how much? Number of possible outcomes, 52. So probability of getting that event should be an ace, is 4 by 52. That is how much? 1 by 30. Now, how to do the second question? Not getting an ace. That means you should not get an ace. How many possible outcomes can be possible here? Not an ace. My event is, suppose this is event 1. My event 2 is, I don't want to get an ace. So if I remove all aces in the shuffle of pack, how many cards will remain, guys?
48, sir.
48.
Number of outcomes favorable to E2, that is 48. Total is 52. So probability of getting event E2 will be equal to 48 by 52. That is equal to 12 by 13. Is it clear, guys? Now, the same question I can do like this. What is the meaning of not an ace? It's a complementary of getting an ace, correct? So
Yes, sir.
here, probability of E1 and E2 are complementary each other. So E1 is asking getting an ace, E2 is asking not ace, other than ace anything. So you can do like this also. Already we got P of E1, getting an ace is 1 by 12. P of E2 can be written as 1 minus P of E1, because E1 and E2 are 1 by 13, sorry. So from here I can write 12 by 13. So using complementary concept also you can solve this question, or without complementary concept also you can solve this question. But if there are very huge number of events, then you can use the complementary concepts. Clear? Shall I go for one more question?
Yes.
A student tosses 2 coins simultaneously. What is the sample space? If a student tosses 2 coins simultaneously, what is the probability of getting? What is the probability of getting at least one head? At least one head. What is this meaning, guys? Anyone can identify the answer? There are two coins. If I toss two coins, what is the total sample space or total sample space or total possible outcomes? Akash, can you tell? See, if it is one coin, either head or tail. If it is two coins, what can be the result? How many ways the result can come?
4 ways, sir. It can either come
Both
as
both may be heads, correct?
yes, sir.
First one is head and second one is tail, or first one is tail, second one is head, or both may be
Both
tails.
tails.
Other than this, any other results can come?
No, sir.
No, sir.
No. So he is asking at least one head. Out of this, how many results are there, or how many favorable outcomes are there for at least one head? How many favorable outcomes are there for at least one head? At least one head means what are the things you can take here? I need at least one head. So this is possible, and this is also possible. So the probability is 3/4. At least one head means it may be at least one head or two heads. So there are three favorable outcomes. Guys, the same question, if I'm asking only tails, what is the answer? That means there is no heads. What is the answer? Probability of getting both should be tails.
1/4.
1/4. No. Probability of getting one head and one tail.
1/2.
1/2.
Simple. Like this, we can able to solve the questions related to probability. This is only the thing we are having. That's it. We will go one question related to die. A person throwed a die. Just I'm not writing here. What is the probability of getting? No, dice. We already done everything. Can you write the sample space if a person throws two dice? Two dice. What is the sample space? How many types, like how many number of sample space you will get? How many number of events can occur like in a sample space? First day will give 6. Second day also will give 6. But
So 2 dices and 6 sides. So 2 times 6,
so
12.
So 6/2 is the answer actually. First day is only 1 with all possible of second day. 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6. If second day is only 2 with all possibilities of the second day. This is a mathematical calculation. This is a theoretical approach. 4, 2, 5, 2, 6. With 3, everything. 3, 2, 3, 3, 3, 4, 3, 5, 3, 6, 4, 1, 4, 2, 4, 3, 4, 4, 4, 5, 4, 6, 5, 1, 5, 2, 5, 3, 5, 4, 5, 5, 5, 6, 6 comma 1, 6 comma 2, 6 comma 3, 6 comma 4, 6 comma 5, 6 comma 6. These are the possible outcomes of a type if you throw 2 dice. If I am throwing 3 dice, I will get 256, which we never asked in 10th standard level. So now, what is the probability of getting the sum of the result is 9? What is the probability of getting the sum of the result is 9? Anyone? How many possibilities are there to get the sum is 9? Sandhya, sum is 9. I'm rounding with blue color.
Sir, 1 and 8.
1 and 8 is possible. Is there in sample space?
Sorry, sir.
First,
Yeah.
7.
1? 7 is also not there now. Sum is 9. Sum of
Yeah,
the
sir. So 7 numbers.
result is 9. Where is the 7? 7. Okay, you are saying 7 possibilities is there, correct?
Yes, sir.
Comma 5. With 1, no chance, correct?
Yes, sir.
Yes, sir.
With 2 also no chance. With 3 there is a chance. 5 comma 4, 4 comma 5. 3 comma 6, 6
So
comma 3.
4 probabilities, sir.
Only 4. No 5, correct? Is there any other alternatives, guys? Is there any other alternatives? Any other things is there? Possibility? Sum should
No.
be 9. So the probability of getting the number 9 is 4 by 36. How much? 1 by 12. What is the probability of getting the sum is 8? Probability of getting the sum is 8.
2, 6,
3, 5.
3, 5, 4, 4, 5.
With 1, is there any possibility? We can come like this. With 1, there is a possibility.
No,
No
sir.
possibility.
No, sir.
With 2,
2, 6.
2 comma 6 and 6 comma 2. With 3,
3, 5.
3 comma 5 and 5 comma 3. With 4,
4
4
comma.
comma 4.
4 comma.
So there are 5 possibilities. So the answer is 5 by 36. Now, the probability of getting the sum is an odd number. The probability of getting the sum is an odd number. How much? Probability of getting the sum is an odd number.
Sir, 2, 1, 1, 2.
So 18.
Correct. Exactly half I can say. See, in each event 3 are there. Suppose if I am taking the first event 1 2, 1 4, 1 6. If I am taking second event 2 1, 2 3, 2 5. Like that each and every time I am having only 3 possibilities is there. So like this 18 possibilities there. So 1 by 2 is getting the odd number. 1 by 2 is getting the sum of the result is even number is 1 by 2. So like this, we are having different examples. It may be with cars, or it may be with some balls kept inside a bag and taking the, or it may be some other examples they might be given. See, understanding the question. Here the question is not bounded for certain thing. It may be any kind of practical question they may ask. We try few questions. One more class I am going to. The day after tomorrow class might be 1.5 hour session. We will conclude different kind of numericals which they are asking in examination related to probability, and I'm going to give one more class related to probability also. At least 45 minutes I will give for the probability class. Like the next class, what we planned. Yeah, actually I planned for coordinate geometry. Anyway, not a problem. At least 40 minutes I will spend the probability and complete. I think which already statistics. You already completed exercise 1 and 2 and 3, and probability complete the first exercise. There is only one exercise. try to complete how much you can able to do, and I'm giving the these assignments need to upload Friday. What are the things you've done in statistics and probability, what are the worksheet I'm giving, you have to complete by Friday. Is it okay, guys?
Yes, sir.
Yeah, I will post
Yes,
a
sir.
message. Ma'am will open the assignment tab in the app. You can upload by Friday. So day after tomorrow class, we will start the coordinate geometry, and as well as, sir, we will wind up the probability. So shall I wind up the class? Any doubts?
No doubt.
Tillai was absent today. Yeah, we'll meet in next class. Bye, everyone.
Thank you, sir.
Thank you, sir.
Thank you.
Thank
Please practice. Any doubts, come for the next class on probability.